Okay, welcome to Saturday Night Data Party. It is Saturday, the 18th of July. Tonight we're taking a look at some data from the popular fan fiction website, Archive of Our Own. Now, if you're unfamiliar with this site, it is essentially a fictional place that you can go and find essentially people writing about pretty much every topic under the sun, including fiction that was set in other universes, like music and bands and movies and television shows. When you dig around in here, let's go ahead into TV shows. Let's pick a TV show. What's a popular TV show? I don't know anything about TV shows. Let's just look for Okay. What's got a lot of data? The A-Team. Yeah, this good old 80s stuff. You'll notice that there's a lot of metadata. There's a title, there's an author, there's tags, there's the language it's in, the words, the chapters, kudos, which is essentially like votes or likes, and then hits, which is the number of views. One of the first things we have to tackle when we deal with any kind of data extraction is we have to figure out how we're going to get the data out of a site like this, because there's no API, there's no provided means to extract this information. And what we really want to get a sense of is where's the data going to come from? So the good news is that for any even moderately popular site on the internet, someone somewhere has already done the hard work of building a piece of code that will extract the data for us. In this case, we're going to use a Python scraper. So let's do Python scraper, just search for this. And of course, our first result comes up on GitHub. This is a script by Radiolarian, and it is open source. It is free to use. It looks like it uses beautiful soup. And then we feed the Python script the URL that we want and have it ingest this data. Now, this we're using Archive of Our Own because it's a fun site to spend some time on. But you can use this type of technology on places like Medium, Forbes.com, Business Insider, any place where there's, again, a popular enough website that somebody will have been motivated at some point to say, hey, I would like to look at some of the data behind this. I'm going to extract it out. Now, to do this, you have to download the scripts to your personal computer, make sure that you have Python installed, and then run them, follow the directions, run them, and extract the information. I took the liberty of doing this in advance for a couple of reasons. One, it takes a really long time. The authors of these scripts do generally a pretty good job of being compliant with the terms of service, which means not trying to grab all this data all at once and overwhelming the site and doing bad things to it. And two, we then need to go and clean it. So what I've done is I've taken that data from the script, and you can see I've got about 1,000 different pieces of story here. I've got ratings, published date, the date it was published, the status was last changed, number of words, number of chapters, comments, kudos, bookmarks, hits, and then using the R library Quantata, we've got 4 readability scores: Coleman-Liao grade level, Flesch-Kincaid score, Del-Chow score, and SMOG, simple measure of gobbledygook, or how many, essentially, do you use a lot of syllables in your text. There's also 4 measures of lexical diversity. So lexical diversity is a term for how broad is the language you use. This is a really good term for not only fiction writing, but also business writing too. Lexical diversity means that you're using a wide variety of words, right? You're not just using the same 25 words over and over again. It's sort of I guess, a proxy for having a broad vocabulary. So we've got, for each story, those. And then using the sentiment library, Sentimenter, we've gone ahead and pulled the sentiment for the 8 major core emotions, positive and negative. All of this gives us essentially a very large table of each of these stories. And by the way, if you're here, say hello in the comments, otherwise I have no idea who's here. And we can see there's our ratings, dates, things like this. Now, the objective we care about is probably going to be something along the lines of what makes a story popular, what gets hits, if you will. So let's get started with that. We've got our data frame here. Let's do something pretty simple to get started, and I want just numerics, meaning numeric data. So I'm going to boil this down. This gets rid of anything in our table that was not a number. Because anytime you're going to be doing like any kind of correlation, you want to get rid of dates and other formats. The other thing we want to do is we want to get rid of what are called near zero variables. And these are variables that have essentially no variance to them, which means that from predictive purposes, they're not going to be very helpful. So let's go ahead and get rid of those. And what do we have here? We're down to 17 variables that have enough variation that we have meaningful information about them. Okay, cool. Let's now go ahead and run a correlation. And we're going to use a Spearman correlation because we have no guarantee that this is a meaningful distribution. And zoom this in. Okay. So when we look at hits here, we see, moderate correlations. Anything over 0.25 in a Spearman p-value is going to be, moderate. Anything above 0.5 is good. So comments, right, is bookmarks at 0.78. It's very strong, and then kudos 0.79. So this is useful. Here's the challenge, and this is something that you have to be very careful when we do this kind of analysis. Hits or views of the content is a number that occurs first, right? Something like a kudos or a bookmark or a comment are things that happen afterwards. You cannot, in no place can you get a comment on a story without someone reading it, right? So sequentially, there's a pattern of time that has to happen before. Whereas things like the number of words in a story, that happens before user interactions. So while it would be great to say, yeah, the more kudos a story gets, the more hits it's going to get, it's actually probably the other way around. The more hits that a story gets, the more kudos it's going to get, because logically, the more people who read the story, the more people who can interact with it. So of the variables we have here that are predecessors to user interaction, which is all these emotions and things like that, we see that of those, these two here, the word count numbers, and those are actually tightly correlated. The word count and negative emotions have the highest correlation. So essentially, we're saying that longer stories may result in more traffic, more views on it. So the next question is, well, is there a way that we could conceivably prove that? The way we're going to try and tackle that is, now that we know that there are some issues in the data set, right, particularly with comments, bookmarks, and kudos, we need to remove those in order to be able to do an analysis of them. So let's do a clean Watson data frame here, and we're going to take our AO3 data, and we're going to select and remove hits. We're going to remove kudos. We're going to remove bookmarks. And we're going to remove comments. Now, we are going to keep in some of those other fields. Okay, so have we got through and removed anything that is user? Okay. Next, let's go ahead and write this out. To a text file on our desktop. Because what we're going to want to do is take this to a different system. And we're going to take it to IBM Watson. Now, what are we going to do here? We're going to feed this data set into Watson and ask it, based on the information we have provided using the Auto.ai functionality, can we design an experiment that can judge better those different characteristics that we're talking about, like lexical diversity and things, and get a better sense of did that not write out? Oh, duh. There we go. Okay, let's call this AO3 test. We're going to create ourselves a new experiment here. Let's load our data. And we want to predict on hits. Run our experiment. Now, for those of you who've never seen Auto.ai before, the name's kind of misleading. It is automated machine learning, but the vast majority of what it does is the data preparation, cleaning, and readying a data set, and then essentially testing different algorithms on it to see does a particular type of data or does a particular type of algorithm work better for this particular data set. So it has just begun. It is going to start looking at the data, doing some analysis on it. It's going to try cleaning it if there's anything that's egregiously wrong with it. And then it's going to start selecting things like what measures should we use, what algorithms, what models would give us the best overall result for essentially predicting those hits, those page views. Again, this is something that you can do with any numerical data. So if you had Google Analytics data, if you have social media data, you can do any of those data types in here as long as you take the time up front to think about the variables that you do and don't want to include, because you can use the built-in data refinery to try and clean it up, but it's not really the best. It's difficult to use. So if we can do that in the prep phase, we can eliminate that step here and go right into picking algorithms. And now what you're seeing is it's gone through and done some hyperparameter optimization. It is now doing feature transformation, where it adds together different data points to see if any of those are relevant, and then it's going to do another round of hyperparameter optimization, which if you think of machine learning model as a stove, right? And you're baking cookies. Hyperparameter optimization would be things like trying to bake a batch of cookies at every degree of temperature between like 200 and 400 for every amount of time between 5 minutes and 30 minutes to see which combination of time and temperature gives you the best cookie. Right, and again, that will depend on some things like the dough, the ingredients in the dough, etc., which is the data in this case. But hyperparameter optimization is literally just fiddling with the knobs on the stove, every possible variation, to see what combination of those external parameters makes the best cookies. So in this case, makes the best possible outcome for the data. Let's take a look while it's still thinking. And take a look at what has come up with feature importance here. So this is really interesting. What this is saying is that the rating, general, mature, explicit, teen, etc., has an outsized impact, and a pretty sizable one on whether something gets hits or not, right? So depending on why somebody might be viewing this particular type of content, we could potentially build a model to predict, like, okay, this this rating or this type of story gets the most interest. If some people who want very explicit content, this may be the thing. So now that we have that knowledge, we could go back to our data and analyze it and say, okay, well, what does that breakdown look like? What are the different ratings, and how do we bucket the number of hits for on average in each of those ratings to see which rating gets the highest number? And that will tell us then, if we were content creators here, write more stories like this. We could also, for example, explode different themes or fandoms. If I wanted to, we started jokingly with the A-Team because I couldn't find anything else very quickly there. But if there's like 5 popular TV shows that people are writing fan stories in, would that make a difference? Probably would. We'd want to know that. That's the power of these systems, the ability for us to very, very quickly get to an answer of, okay, here's what looks like has an outsized impact on this objective. Now we can go back and start refining our data and get to a point where we can build a hypothesis. That's the data science portion of this. Is if we find out, for example, that explicit content is the thing, then our hypothesis is if I create content that is explicit, it will get more views. Chip asks, can you drill in to see which ratings are driving it? Not in here. Again, we have to go back to our original data set and parse that out separately in order to make that determination. In fact, let's see if we can do that in a reasonably timely fashion. Let's start with our straight data set here. And we'll do a slim AO3. You have to start with AO3 data. And we just want to use rating and hits. Oh, I don't need that second parenthesis there. And let's do a group by rating and a summarize. Let's do mean. Average hits equals mean hits. Let's see if... Okay, so we've done our summarize. Let's take a look at our slim data set here. 5 observations, 2 variables. And as suspected, yep, explicit followed by mature. Teen and up, not rated, general audience. So to Chip's question, yes, we can very quickly go in now and see what it is that gets that. Now again, think about how you would use this with like data from, say, Medium. If you have like content topics, like what topics get the most clicks on Medium. If you have the data, you can then do exactly what we just did. Say like, I've got to write political stuff if I want to be popular on Medium. If you do it with YouTube and use YouTube's categories, I need to make videos about, I don't know, a Kardashian in order to be popular on YouTube. Whatever the case is, we can find that data very, very quickly by first running it through Watson to give us that massive, massive regression analysis, and then jumping back into our data to look here, and now we have a hypothesis that we can go test. So, good question, Chip. So that's tonight's exercise. Tonight's fun is looking at how do we use these tools together to build a better hypothesis that we can then go test. Because a lot of the times we struggle in marketing with we just test things randomly because we don't have a data-driven hypothesis. This is the process for doing that exploratory analysis to find out what should we be hypothesizing in order to create a meaningful outcome. So if you have follow-up questions, please join the free Slack group that comes with this stuff. Go to trustinsights.ai/analytics for marketers. Totally free to join. Again, trustinsights.ai/analytics for marketers. And you ask questions about this or any of the other shows that we've done. If you have wondering, like, is there a way to do it with LinkedIn data? Spoiler alert, there's not. LinkedIn is notoriously bad about locking, well, good for them, locking down their data like crazy. But other things, you could do the exact same process, say with emails in your customer service inbox or chat logs on your company website. Exact same process, just with a different data set. So thanks for watching. I'll talk to you folks soon. Take care. Want help solving your company's data, analytics, and digital marketing problems? Visit trustinsights.ai today and let us know how we can help you.